Hi, my name is Surinder Analalaki Gopalakrishnan. Today I'll be presenting my topic titled Exploring the Impact of Noise on Modulation Technique using AI Simulate Data. This is a part of our communication principle course BERT2333 and I'm proud to present this under the guidance of you, Doctor. Let's start by your introduction. Okay, the background is modulation is a part of is a type is a key part of sorry for the disturbance, sorry for my error. Okay, modulation is a key part of a communication system. It helps us send data by changing, charging, or encoding it onto a carrier signal. Some common modulation method includes BPSK, QPSK, and QAM. However, these methods are sensitive to noise, which can come from interference, electronic device, or even the environment. So, in this study, I want to explore how noise affect different modulation techniques and how we can understand this using AI and simulation tools.
Hello, my name is Kamila Ramagong. Matrix number B122331032. My part, I'm gonna present about traditional versus AI based on analysis. Traditional methods is equal to physical, experiment, mathematical model, and basic simulation. And the second one is limitation and not limitation is not scalable and struggle to model real world complexity. And then number three is AI tool like ChatGPT, Gemini are faster, more accurate simulation and better modeling of complex noise environment, flexible testing across various SNR noise type.
To carry out this project, I followed a few simple steps. First, I used AI tools like ChatGPT and Gemini to collect background theory and understand the basic of noise and modulation. Second, I used MATLAB Simulink to create simulations and I focused on AM, FM, and SSB modulation types. I added a noise to each of them to see how they behave. Third, I watched YouTube tutorials to visualize, understand how simulations are done and how modulation reacts in real life scenarios. Lastly, I examined the simulation result and made some conclusions about which modulation method is more affected by noise. Thank you for listening to my presentation and I hope you gain a clear picture of how noise affects modulation.
Hello, my name is Cecily and I'm going to present for result and simulation for programming code for this communication principle assignment. At the first one, we have AM modulation, and as we can see at here, we need to define every parameter that we need for this assignment, and then we did the mathematical or logical operation, and we can calculate the value of FC, FM, so we can compute the result. And as for this part, we compute the result, so the operation that we did at here can display at result when we run the simulation. So as for AM modulation, this is the result of impact of noise on AM modulation. And this is the clear result for AM modulation, which is the first one is original message signal, the second one is carrier signal, and the second one is AM modulated signal with noise impact. And the second one is FM modulation, and here is the same as AM modulation. We need to define every parameter that we needed for this coding and program. And the first one, we need to define carrier frequency, message frequency, sampling frequency, duration, time vector, amplitude of message, message signal, carrier amplitude, frequency sensitivity modulation, index factor, and so on. And then after that, we need to do the mathematical operation, as we can see here, which is integrate the message signal for FM and FM modulated signal. Here is we do the calculation of modulated signal, and then here is for code that we need to add, that we needed to add the noise to this code. And then here is the coding for showing the result of this simulation when we run the simulation. And here is the result for impact of noise on FM demodulation. And then here is another result for this simulation. The first one is original message signal, and the second one show the carrier signal, and then the third one show the FM modulated signal. And then this is kind of different from AM modulation, as we can see in here. And then moving to the next part, which is SSB modulation. This is the programming for SSB modulation, same as AM modulation and FM modulation. We need to define every parameter that needed for this programming. And we did all this code programming in MATLAB Simulink, and we developed the program for this simulation with help of artificial intelligence application like ChatGPT or Gemini. And as we can see in here, the first one, we need to define FS, T, FC, FM, the same as AM, and FM modulation. And we need to do the calculation. And then we did the coding so we can show the result when we run the simulation, same as previous part. And then this is the result for SSB modulation. And then this is message signal, the result for message signal. And then this is for SSB modulated signal, upper segment. And then this is SSB signal with Gaussian noise, which is the value of SNR is 20 decibel. And then this is the SSB signal with impulse noise. So from this modulation, we can see that we can see that the difference of AM modulation, FM modulation, and SSB modulation, which is the noise resistance. As for AM modulation is quite poor, which is for FM modulation is quite excellent, and SSB modulation is moderate and good. And as for bandwidth usage, AM is 2 times message wide, and for FM is wider. Meanwhile, for SSB is very narrow, which is only carry one message. And as for audio quality, AM having a medium low in audio quality, and FM is have a high audio quality, and SSB is the medium in audio quality. And as for efficiency in terms of power, AM have lowest efficiency in power amongst these modulation. FM have the medium efficiency in power, and SSB have the highest power of this modulation. And for the last one, as for complexity, AM modulation is more simple compared to FM and SSB modulation. And as for FM modulation, it is more complex compared to AM, and the same goes to SSB. And to conclude, AM is most affected by noise, which is not the ideal for high quality transmission. And the same goes to SSB, which is a compact and power efficient option with moderate noise resistance. But SSB is more modulation is more ideal for long distance or mobile communication. And as for FM, is the most robust to noise, and making it very perfect for high fidelity audio like music and public broadcasting. As we can see in real life, we can see FM modulation apply a lot at radio, as we can always listening to. And then that's it for part. As for result, simulation code, simulation and programming code for this assignment.
And then lastly, this is our conclusion and for the future work. This study show how BPSK, QPSK, and QAM are affected by different noise types using MATLAB and AI simulation. BPSK is most noise resistant. QPSK offers a good balance, and QAM provides high speed but is more noise sensitive. AI tools prove useful for accurate noise simulating. Future work can explore higher order modulation, AI-based noise reduction, and real-world testing with FPGA or SDR system. That's all. Thank you.